Hi guys, welcome to my YouTube channel. Today my topic is what are solids and what are their types. So let us discuss our topic. Firstly, the introduction of solids. Solids are those substances which are rigid, hard, and have the definite shape and definite volume. The atoms, ions, and molecules that make up a solid are closely packed. They are held together by strong cohesive forces. The constituent atoms, ions, or a molecule of a solid cannot move at random. There exists a well-ordered arrangement in solids. There are many types of solids. So let's solids can be classified on the basis of the regular arrangements of constituent atoms, ions, or molecules. There are two types of solids in the respect: crystalline solid, amorphous solid. So what is crystalline solid? Those solids in which atoms, ions, or molecules are arranged in a definite three-dimensional pattern are called the crystalline solids. This requiring regular geometric pattern of the structure extends three-dimensionally. What are the amorphous solids? All the solids are not crystalline. The word amorphous means the shapeless. Amorphous substances are those whose constituent atoms, ions, or molecules do not possess a regular orderly arrangements. The best examples are glasses, plastic rubbers, glue. These substances have solid state properties and virtually complete maintenance of a shape and volume, but they do not have a ordered crystalline state. Many crystalline solids can be changed into the amorphous solids by melting them and cooling the molten mass rapidly. In this way, the constituent particles do not find the time to arrange themselves. A long-range regularity does not exist in amorphous solids, but they can possess small regions of orderly arrangements. These crystalline parts of the otherwise amorphous solids are known as the crystallites. Amorphous solids do not have sharp melting points, and that is the way the particles of the glass often over a temperature range and can be modulated and blown into the various shapes. They do not possess the definite heats of fusion. There are some properties of crystalline solids. So let me discuss. Firstly, the geometrical shape. All the crystalline solids have a definite, distinctive geometrical shape due to the definite orderly arrangement of atoms, ions, or molecules in their three-dimensional space. For a given crystal, the interfacial angles at which the surface interact are always same, no matter in which shape they are grown. The faces and the angles remain the characteristics even when the material is ground to find the powder melting point. Crystalline solids have sharp melting point and can be identified from uh, their definite melting points, cleavage planes. Whenever the crystalline solids are broken, they do not show along the definite planes. These planes are called the cleavage planes, and they are the inclined to one another at a particular angle. For a given crystalline solid, the values of this angle varies from one solid to another solid. And fourth property is anisotropy. Some of the crystals shows variation in the physical properties depending upon their direction. Such properties are called the anisotropic properties, and the phenomenon is referred to as an anisotropy. The physical properties of the crystalline solid, like refractive index, coefficient of thermal expansion, electrical and thermal conductivity, are sometimes anisotropic in nature for some crystals. The variation in these properties with the direction is due to the fact that the orderly arrangement of the particle in the crystalline solid is different and in different direction. For example, the conductivity of the graphite is greater in one direction than in another. Actually, the electrons in the graphite are mobile for electrical conduction parallel to the layers only. Therefore, its conductivity in the direction is far better than the perpendicular to the other direction. Similarly, The cleavage itself is an isotropic behavior. Symmetry. The repetition of faces, angles, or edges when a crystal is rotated by 360 degree along its axis is called symmetry. This is an important property of a crystal, and there are various types of asymmetrical elements found in crystals like center of asymmetry, plane of asymmetry, and the axis of asymmetry. A sixth one property is the habit of a crystal. The shape of the crystal in which it usually grows is called the habit of a crystal. Crystals are usually obtained by cooling the saturated solution or by slow cooling of the liquid substances. These are formed by the growing in various directions. If the condition for a growing crystal are maintained, then the shape of the crystal always remains the same. And if the conditions are changed, the shape of a crystal may change. For example, the cubic crystal of NaCl become the needle-like when 10% of urea is present in its solution as an impurity.